distribution. If a random variable has a probability distribution whose graph is continuous, bell-shaped, and symmetric, it is called a normal distribution. Its graph is called a normal distribution curve.
This distribution is also known as the Gaussian distribution curve, named after the German mathematician Carl Friedrich Gauss, who derived its equation.
The discovery of the equation for a normal distribution can be traced to three mathematicians. In 1722, the French mathematician Abraham de Moivre derived an equation for a normal distribution based on the random variation of the number of heads appearing when a large number of coins were tossed. Not realizing any connection with the naturally occurring variables, he showed this formula to only a few of his friends. About a century later, two mathematicians from France and Germany named Pierre Laplace and Carl Gauss respectively derived the equation of the normal curve independently and without any knowledge about de Moivre's work. In 1924, Carl Persson found that de Moivre had discovered the formula before Laplace and Gauss did. So why exactly was this distribution also named after Gauss when there was actually another person that discovered the same thing before he did? Well, we don't know.
What? This is the equation of a normal distribution.
The shape and position of a normal distribution curve depend on two parameters, the mean and the standard deviation. Suppose one normally distributed variable has a mean of 0 and a standard deviation of 1, and another normally distributed variable has a mean of 0 and a standard deviation of 2. Both distributions have the same mean, but different standard deviations. When the standard deviation increases, the shape of the graph spreads out. What will happen if it is the other way around? The shape of the curves will be the same, but will have different means, as you can see in the picture.
So here are the properties of a normal distribution. A normal distribution curve is bell-shaped. The mean, median, and mode are equal and are located at the center of the distribution. A normal distribution curve is unimodal. The curve is symmetric about the mean. The curve is continuous. The curve never touches the x-axis. The total area under a normal distribution curve is equal to 1. The area under the part of a normal curve that lies within one standard deviation of the mean is approximately 68%, within two standard deviations, about 95%, and within three standard deviations, about 99.7%.
Now, we are going to find or solve the areas under the normal curve. First, we need to recall what a z-score is. The z-value or z-score is the number of standard deviations that a particular x value is away from the mean. Then, we will be using a table that gives the area under the standard normal curve for any z-value.
There are two steps to find a particular area under a normal distribution graph. First, you need to draw the normal distribution curve and shade the area asked in the problem. There are three cases that can occur. 1. To the left of any z-value, look up the z-value in the table and use the area given. 2. To the right of any z-value, look up the z-value and subtract the area from 1. And 3. Between any two z-values, look up both z-values and subtract the corresponding areas.
The normal distribution curve can be used to solve a wide variety of practical problems. The only requirement is that the variable be normally or approximately normally distributed. To solve problems like these, we need to transform the original variable to a normal distribution variable by using this formula. This formula transforms the values of the variables into z-values. Once the variable is transformed, then we can now use the table that gives the area under the standard normal curve for any z-value and the three cases that might occur.